Hi friends, this is Dr. Yata Praveen Kumar. Today I am going to explain the mass spectrometry. So what is mass number? Before going to mass spectrometry, we need to know mass number. The mass number, also called atomic mass number or nucleons number, is the total of proton and neutrons in an atomic nucleus. So these are the number of protons, Z number of neutrons. Combination of this is called mass number, that is A. For example, carbon atom have 6 protons and 6 neutrons. In the center of the nucleus, 2 electrons situated in the inner orbital, whereas other 4 electrons are outside of the orbital. Like this, we have carbon, 6 number of protons and mass number is 12. We can represent the carbon atom like this. This is 6 protons and 6 neutrons in the nuclei, and these are the 6 electrons in the outer orbital. Common elements and mass number. For example, we have some common elements and their atomic weight and valency. Carbon 6, atomic number is 12 and valence is 4. That's why we have 4 catenation of the carbon. And hydrogen 1 atomic weight and valence is 1. Oxygen 16 atomic number, valence is 2. Sulfur 32 atomic number, atomic weight, valence is 2. Phosphorus atomic weight is 31, valence is 3. Fluorine atomic weight is 19, valence is 1. And chlorine atomic weight is 35, valence is 1. Bromine atomic number is 79 and valence is 1. Iodine 127, valence is 1. And nitrogen 14 atomic weight, valence is 3. What is mass spectrometry? Mass spectrometry is an instrumental technique in which sample is converted to rapidly moving positive ions by electron bombardment, and charged particles are separated according to their masses. So what is the mass spectrum? Mass spectrum is a plot of relatively abundance against the ratio of the mass by charge ratio. So mass spectrometry, what we understand, what we know by using of this mass spectrometry. Mass spectrometry is an analytical spectroscopic tool primarily concerned with the separation of the nucleons and atomic species according to their masses. What information can be determined? So we should know by using of this mass spectrometry molecular weight, molecular formula by using of HRMS, high resolution mass spectrometry, and structure from fragmentation of fingerprints, isotopic incorporation or disturbances, protein sequences. So basic theory of mass spectrometry and loss of an electron from a molecule leads to radical cation. So this is a molecule, loss of an electron will convert into radical cation. This is we call radical cation. This is a parent ion, and when we apply the 15 electrovolts of energy, it will remove one electron, it will convert into radical cation. By this radical cation, this is a, we call it a molecular ion. By this molecular ion, we can apply 70 electrovolts. By observing this energy, it will split into variety species of fragments like cations, radicals, neutral molecules, radical cations. Such type of fragments will give the structural information of and their molecule. This is the instrumentation of the mass spectrometry. So we have a sample inlet, sample, electron beam and filament, and neutral molecule, neutral fragments and negative ions in vacuum pump, and this is a positively charged repelled plate and negatively charged acceleration and focusing plates. These two are magnitudes which we observe the speed and which we measure the speed of the positive ions, and analyzer tube, and finally positively charged ions deflected according to the mass by charge ratio, ion exit slit and collector, and finally recorder. So ion sources, we have certain type of ion sources. The ion source is the part of the mass spectrometer, the ionage of the material under the analyze. The ions are the transported by the magnetic or electric field of the mass analyzer. Molecular ions are formed when energy of the electron beam reaches 10 to 15 electrovolts. Fragmentation of the ions reaches only at higher bombardment energies at 70 electrovolts. So ionization methods divide into two categories. One is gas phase ionization Another one is the desorption technique or liquid and solid. First one, gas phase ionization, gas and vapors. Samples are ionized outside the ion sources. This technique includes electron impact ionization EIS, chemical ionization CI, field ionization FI. And another category is desorption technique, that is it is used in liquid and solid samples. Samples are ionized inside the ion sources. This technique includes field desorption FT, fast atom bombardment FAB, and laser desorption LD. These are some of the ionization methods in mass spectrometry. These are the ionization methods: electron impact ionization, chemical ionization, electron spray ionization, fast atomic bombardment ionization, field ionization, MALDI, plasma desorption, APCI, SIMS, and laser desorption. And what type of compounds when we using this ionization method, and similarly the mass range of based on the mass range we can use this type of ionization methods.